In the vast expanse of space, 4,000 light-years from Earth, lies one of the most extraordinary worlds ever discovered. A planet made almost entirely of diamond. Meet PSR J1719-1438b, a world that defies our conventional understanding of what a planet can be. This incredible object, discovered in 2011, orbits a rapidly spinning pulsar in the constellation Serpens. Despite having a mass greater than Jupiter, this remarkable world has been compressed into an object roughly the size of our solar system's largest planet. But unlike Jupiter's gaseous nature, this planet is solid, crystallized carbon compressed into an enormous diamond. To put this in perspective, imagine taking something heavier than Jupiter and crushing it until it's incredibly dense. The pressure is so intense that the carbon atoms align into a crystalline structure, essentially creating a diamond the size of a planet. Located in the constellation Serpens, this diamond world has captured the imagination of both scientists and the public, representing one of the most valuable objects in the known universe, though its hostile environment makes any dreams of mining it impossible. The discovery of this unique world was made by an international team of astronomers using the Parkes radio telescope in Australia. They were searching for pulsars when they found something extraordinary, a planet with the density of a white dwarf star. The detection came from careful observation of the pulsar's regular radio pulses, which showed tiny variations indicating the presence of an orbiting companion, our diamond planet. What makes this discovery so significant is that it represents an entirely new class of planets, one formed from the remnants of a dead star, compressed to densities we can barely comprehend. The surface of this world would be unlike anything we've ever seen, a smooth, reflective expanse of crystalline carbon, forever bathed in the rhythmic flashes of its pulsar host. This discovery has forced us to reconsider what we thought we knew about planetary formation and the fate of stellar systems. It stands as a testament to the incredible diversity of worlds that exist in our universe and the mysteries that still await our discovery. The story of our diamond planet begins with two stars locked in an eternal dance around each other, a binary system where one star was significantly more massive than its companion. Initially, these stars coexisted peacefully, but as the larger star aged, it began to influence its smaller companion in dramatic ways. The gravitational forces between them grew stronger, pulling them closer together. As the more massive star reached the end of its life, it exploded in a supernova, leaving behind a rapidly spinning pulsar. This violent event marked the beginning of our diamond planet's formation. What happened next was like a cosmic version of peeling an onion. The intense gravitational pull of the pulsar began stripping away the outer layers of its companion star. Layer by layer, the companion star lost its outer shell of hydrogen and helium. The pulsar's powerful gravity acted like a cosmic sculptor, gradually revealing what lay beneath. Today, this remnant world completes an orbit around its pulsar host every 2.2 hours, moving at incredible speeds through space in an endless race against gravity. At this breakneck pace, the diamond planet experiences extreme forces that help maintain its crystalline structure. The pulsar's radiation bathes it in regular flashes of intense light, like a cosmic lighthouse. What remained after this stellar strip mining was primarily the carbon core of the original star. Under the immense pressures and temperatures, this carbon began to crystallize. The pressure was so intense that the carbon atoms had no choice but to arrange themselves into a diamond crystal structure. This process occurred throughout the entire remnant, creating a world of pure diamond. This transformation from star to diamond planet represents one of the most extreme makeovers in the cosmos, a testament to the incredible forces that shape our universe and the unexpected forms that stellar evolution can take. To understand how a planet-sized diamond forms, we need to explore physics at its most extreme. where the fundamental forces of nature create conditions beyond anything we experience on Earth. The diamonds we know on Earth form under immense pressure, about 50 miles below the surface. But the pressures inside PSR J1719-1438b dwarf anything our planet can produce. The pressure at the center of this diamond world is estimated to be millions of times greater than at Earth's core. Under such extreme conditions, carbon has no choice but to crystallize into diamond. From surface to core, the entire planet experiences pressures so intense that the carbon atoms are forced into perfect crystalline alignment. This creates a diamond structure that extends throughout the entire world. Despite having 1.4 times the mass of Jupiter, this diamond planet is compressed into roughly the same size. This makes it incredibly dense, far denser than any natural planet we've discovered. To put this density in perspective, a teaspoon of material from this planet would weigh several tons. The gravitational forces on its surface would be crushing, making it impossible for any human to stand there. The crystal structure of this world is essentially a giant diamond lattice. Carbon atoms arranged in a repeating pattern that extends for thousands of miles in every direction. If we could somehow withstand the crushing gravity and intense radiation, we would see a world that sparkles unlike anything in our solar system. A perfectly aligned crystal structure on a planetary scale. This incredible density is maintained by the intense gravitational forces between the planet and its pulsar host. Their close orbit keeps the pressure high enough to maintain the diamond structure. And speaking of incredible things you won't want to miss, if you're fascinated by these cosmic extremes, hit that subscribe button to journey with us through more of space's most extraordinary objects. Now, let's continue exploring how these gravitational forces shape our diamond world. This planet serves as a natural laboratory for testing our understanding of physics under extreme conditions. It helps us verify theories about how matter behaves when subjected to incredible pressures and temperatures. Imagine standing on a world where every surface, every mountain, every grain of sand is made of pure diamond. Let's explore what it would be like to visit this extraordinary planet. The surface would be unlike anything we've seen before. A vast expanse of crystalline perfection stretching to the horizon, reflecting the starlight like an infinite mirror. Every 2.2 hours, this world races around its pulsar host, which sends out regular pulses of intense radiation. These pulses would create an otherworldly light show on the crystal surface. The pulsar's beams would strike the diamond surface and create dazzling displays of refracted light, turning the entire world into a cosmic light show of unprecedented scale. But this beautiful world would be lethal to visit. The surface gravity would be so intense that any human would be instantly crushed. The temperature soars to thousands of degrees. The surface temperature is estimated to be around 3,000 degrees Celsius, hot enough to melt steel. The radiation from the pulsar would be millions of times more intense than Earth's strongest solar flares. The combination of crushing gravity, extreme heat, and deadly radiation creates an environment more hostile than the surface of any planet in our solar system. The intense pressure has created a world of perfect atomic alignment. Every carbon atom is locked in place, creating a crystal structure of unprecedented size and purity. If we could somehow survive on the surface, we would be standing on the largest and most perfect crystal structure known to exist. The atomic perfection would extend for thousands of miles in every direction. The pulsar's regular flashes would create an eerie rhythm of light and darkness. Every few milliseconds, the entire world would be bathed in intense radiation, then plunged into relative darkness. This strobe-like effect would turn the crystalline landscape into a natural light show, with each pulse of the star creating new patterns of reflection and refraction across the diamond surface. The diamond planet PSR J1719-1438b serves as one of nature's most extreme laboratories. pushing our understanding of physics to its limits. By studying objects like this, we can observe how matter behaves under conditions impossible to recreate on Earth. These cosmic laboratories test our theories about fundamental physics in ways no human-made experiment could. This remarkable world challenges our very definition of what makes a planet. It began as a star, transformed through stellar evolution, and now exists as something between a planet and a stellar remnant. Unlike traditional planets that form from dusty disks around young stars, this world emerged from the stripped remains of a dying star. This forces us to expand our understanding of how planets can form. The density of this object puts it in a class of its own, somewhere between conventional planets and white dwarf stars. It represents a new category of stellar remnant that we're still trying to understand. The existence of the diamond planet reveals new possibilities in stellar evolution. It shows us that binary star systems can produce exotic objects we never imagined possible. This discovery suggests there might be many more exotic worlds out there, formed through similar processes of stellar cannibalism and transformation. Each one could teach us something new about the universe. By studying how carbon behaves under such extreme pressures, we gain insights into material physics that could have applications ranging from industrial diamond production to understanding planet formation. The pressures that created this diamond world are teaching us about the limits of matter transformation and the conditions necessary for crystal formation on a massive scale. As our telescopes become more powerful and our understanding grows, we may find more of these extraordinary worlds, each one helping us piece together the puzzle of our universe. The Diamond Planet stands as a testament to the incredible diversity of our universe and reminds us that we've only begun to scratch the surface of what's possible in the cosmos. Thank you for joining us on this journey through one of space's most extraordinary discoveries.